So the last section, 4.3a, was completing the square and the square root method to solve for problems. And the method that we used there worked good because we were looking at values or equations where our a always had a value of 1. But sometimes you're not going to have that. Sometimes your a is going to be a value greater than or less than 1 if it's a negative value. So you have to look at a couple more things when you're completing the square for that one. So we're looking at 2x squared minus 5x minus 1 is equal to 0, and we want to solve this by completing the square. So same steps as before, as in the last section. We're going to get the c value to one side of the equation. So 2x squared minus 5x minus 1 means we're going to move that minus 1 over, so it's going to be a plus 1. There shouldn't be a step 7. So 2x squared minus 5x is equal to 1. So we want to factor the value out, the a value out of the left side. So if I factor a 2 from here, that means I'm going to be left with x squared minus 5. So when I factor by 2, that means I divide by 2. Step number 3 says I want to divide both sides by the a value, so I'm left with an x squared plus bx on the left side of the equation. And then from there I take that b value and half it. So I have a 2 in here. So in order to get rid of that 2, that means I'm going to have to divide both sides of my equation by 2. So this 2 will take care of itself, so I'm left with x squared minus 5 over 2x is equal to 1/2. So now that's the equation that I'm going to do the completing the square from. So all I've done is I've GCF'd the 2 out of the first two terms, and then I divided by 2 to get rid of it from my equation so that I can just complete the square. So my b value is 5 over 2. I guess it's negative 5 over 2. So my negative 5 over 2, if I half that, so if I'm dividing by 2, it's like multiplying by 1/2, so it's going to equal negative 5 over 4. And remember, this is the value I keep for later, and then I square it. So that equals 25 over 16. So that 25 over 16 is the value that I use to add on to both sides of my equation. So step 4 says to add the number from step 3 to both sides of the equation. So that b value I add to both sides. So I have x squared minus 5 over 2x plus 25 over 16 equals 1/2 plus 25 over 16. So remember, because I've put it on the right side of the equation, instead of subtracting 25 over 16, I add 25 over 16. So now I have my trinomial on the left, so I'm going to factor that. So this is x minus, I use my star value, minus 5 over 4 all squared is equal to 1/2 plus 25 over 16 is the same as 8 over 16 plus 25 over 16. So x minus 5 all squared is equal to 33 over 16. So I have my squared on one side and my value on the other, so I use the square root property now. So that means I square root this side of the equation, square root the right side, excuse me. So I have x minus 5 over 4 is equal to plus or minus square root of 33, and the square root of 16 is a 4. So now I have to finish solving, so that means this minus 5 over 4 has to be added to both sides. So x is equal to, and I'll put that in front, 5 over 4 plus or minus square root of 33 over 4. Now this one works out kind of nice because we have the same denominator. We have a common denominator, so what that means then is that we can rewrite this so it just has one denominator. So x is equal to 5 plus or minus square root of 33 all over 4. So you could write it as x is equal to 5 plus square root 33 over 4, or x is equal to 5 minus square root 33 over 4. Or you can just put them both together like that, and your solution is done. Okay, in the next example, we're going to do the same thing, complete the square. This one it says answer b to the nearest hundredth. So that means we're going to look at actually finding the answer, not an exact value, but a rounded value to the nearest hundredth. Okay, so in A, I have 3x squared minus 2 is equal to negative 4. Well, this is my c value, that negative 2. It has to go to that side of the equation, which means that this minus 4x has to come to the left side of the equation. So what I have then is 3x squared plus 4x is equal to positive 2. Now, just like I did in the other equation, I can't have this 3 in front. I want it to be a 1, so that means I'm going to GCF a 3. So I have x squared plus 4 over 3x is equal to 2. So my next step then was to get rid of that 3 in the front. So I divide by 3, and same rule always apply. Whatever you do to the right side of the equation, you do to the left. So I'm left with x squared plus 4 over 3x is equal to 2/3. So now I can do my complete the square. So my b value was 4 over 3. I have to have it, and the little note over here says an easy way to half a fraction is to double the denominator. Because if I'm dividing by 2, I'm multiplying by 1/2, so it means I go 4 times 1, 3 times 2 to get 6. So this is 4 over 6. This is the value I keep. I square it to get 16 over 36. Okay, now you might have noticed, and actually I am going to change that. When I did my 4 over 6 here, I could actually reduce that to a 2 over 3. Nicer number to work with because it's in simplest terms. So I'm actually going to use that 2/3 instead to get a 4 over 9. Your answer would still work out. If you left it as the 16 over 36, you just have to reduce it at the end. This way, if you reduce it right away, then you have a smaller number to work with and don't have to worry about doing that later. Okay, so to complete the square, I have x squared plus 4 over 3x plus 4 over 9 is equal to 2/3 plus 4 over 9. So this becomes, this is a perfect square, so I have x plus, and this is my keep value, is 2 over 3 all squared is equal to 2/3 plus 4/9. So my common denominator would be a 9, so I multiply top and bottom by 3 to get 6 over 9 plus 4 over 9. So x plus 2/3 all squared is equal to 10 over 9. So now I have the squared on one side, I have the square root on the other. So now I can do my square root property. So squared and square root cancel. X plus 2 over 3 is equal to square root of 10. It's not a perfect square, so I leave it. But square root of 9 is 3. So now to solve for x, I am going to subtract my 2/3 from both sides. So x is equal to negative 2/3 plus or minus square root 10, square root 10 over 3. And again, I have that common denominator, so I can write this so it's all over 1. So x is equal to negative 2 plus or minus square root 10 all over 3. And that's your solution. The answers in the back of the book, they might flip and have the plus or minus 10 in front, and then the minus 2. Doesn't matter. If you actually calculated it out, you would still get the same value. Okay, B is the one that we want to work out when we get to the end. We'll actually solve it into decimal form. Okay, so negative 2x squared minus 3x plus 7 is equal to 0. So first thing, I've got to move that 7 over. So minus 2x squared minus 3x is equal to negative 7. Next thing I want to do is I need that negative 2 out of there, so I'm going to GCF by negative 2. So this becomes 3/2 x. If I GCF by a negative 2, that means I'm dividing the terms by negative 2. So my negative 3 becomes a positive 3/2. So the next step, I want to get rid of my negative 2, so I divide both sides by negative 2. So I'm left with x squared plus 3 over 2x is equal to 7 over 2. So my b value is 3 over 2. If I have that, it's like multiplying. Have that is, sorry, just doubling the denominator. So this becomes a 3 over 4. That's my keep value. Square it to get 9 over 16. So I have x squared plus 3 over 2x is plus 9 over 16 equals 7 over 2 plus 9 over 16. So I have my perfect trinomial. This becomes x plus my keep value of 3/4. 7 over 2 to become a denominator over 16, means I multiply by 8. So this is 56 over 8 plus 9. Oh, sorry, 56 over 16 plus 9 over 16. So I have x plus 3/4 all squared is equal to 65 over 16. So now I'm at the square root property step. Square root my left side, square root my right side, square root cancel. So x plus 3 over 4 is equal to plus or minus square root of 65 over 4, because the square root of 16 is 4. I need my x by itself, so I subtract 3/4. So x is equal to minus 3/4 plus or minus square root of 65 over 4. I'm just going to, x is equal to negative 3 plus or minus square root of 65 common denominator, so it's all over 4. So for this one, it wanted us to figure out the value, so that's what we're going to do. I'll just do it up here. So I want to find out what is x minus 3 plus square root 65 over 4. So this is negative 3 minus, and square root of 65 is about 8.06 over 4, which is negative 2.7. 0.77. That's rounded. Your other solution would be x is equal to negative 3. Oh, this should be a minus in that first one. So plus square root of 65 all over 4. So this is negative 3 plus 8.06 divided by 4. So 1.27. So my solutions for this are x is equal to negative 2.77 and 1.27. Okay, so once you have your solutions, you write your solution set, and you're done. Okay, next example. This one's exact same steps as what we were doing, but what's going to be different is what we do at the end, because at the end of this one, we're not left with a perfect square in the bottom. We're left with a square root. So we have to do one more step. And you may have done these steps already. I can't remember, and I'm not sure what you did in grade 10. So we'll see if it's new or not. So we're going to solve this by completing the square. So I have 3x squared plus 6x minus 1 equals 0. Same steps. I have to move my c value. So this becomes 3x squared minus 6x equals 1. GCF my 3 from the front. So that means I divide each of these two terms by 3, so I have a minus 2x equals 1. I want to get rid of that 3 in the front, so I have to divide by 3, and I have to divide both sides. So I have x squared minus 2x is equal to 1/3. Next part, complete the square. So my b is equal to negative 2. Negative 2 divided by 2, or half of it, is negative 1. Keep that. Squared is equal to a 1. So I'm going to add 1 to both sides. Oh, sorry, one mistake. These should be plus signs in here. So just wherever I had a minus 2x, change that to a plus 2x. So my factors for this then, I have my trinomial, which is what I wanted. So x plus 1 all squared is equal to 1/3 plus 1. So 1 is the same as 3/3. I'll just write that here. 1 is equal to 3/3. So I have 1/3 plus 3/3. So x plus 1 all squared is equal to 4/3. Okay, so now I have it to the point where I can use my square root property. So I square root my left, square root my right, squared and square root cancel. X plus 1 is equal to plus or minus. Square root of 4 is a 2, that works out, but my denominator doesn't. So it has to stay as a square root 3. But proper math, or your math grammar if you want to think of it that way, says you can't leave a radical in the denominator. So what we do is called rationalizing the denominator. Okay, we can't have a radical in the denominator, so we must rationalize the denominator. And all rationalizing the denominator means is that whatever the radical is on the bottom, we're going to multiply that to the top and bottom of that fraction. So this, and I'll just continue it up here, and I'm just looking only at the radical side. Nothing changes on this side. So x plus 1 is equal to plus or minus 2 over square root 3. Since square root 3 is the radical I want to get rid of, then I multiply by square root 3 over square root 3. Okay, square root 3 over square root 3 is just multiplying by 1. Multiply an equation by 1, nothing changes. Or multiply a value by 1, and nothing changes. So 2 times square root 3 is just 2 square root 3 with my plus or minus. Square root 3 times square root 3 is just square root 9. Square root of 9 is just a 3. So basically what's happening is you're just dropping, when you rationalize the denominator, you're dropping that square root sign and keeping the value in it. Another teacher that I've taught with calls it booting the root. So basically you're getting rid of the root sign, keeping the value. So now I can finish solving this. X plus 1 equals plus or minus 2 square root 3 over 3. So that means I have to subtract 1 from both sides. So I have x is equal to negative 1 plus or minus 2 square root 3 all over 3. Remember that 3, or the denominator 3, is only over that plus or minus 2 square root 3. So if I want to finish this off so it's in proper math grammar, my negative 1 as a denominator of 3 is the same as negative 3 over 3. So x is equal to negative 3 over 3 plus or minus 2 square root 3 over 3. Now those both have the same denominator, so x is equal to negative 3 plus or minus 2 square root 3 all over 3. And I could have just done that in one step. I could have just went negative 3 from this step here. So that is your solution. So the last part is a problem-solving one. So we can use complete the square and the square root property to solve problems. So it says Bouchard Gardens wants to build a pathway around its rose garden. The rose garden is currently 30 meters by 20 meters. The pathway will be built by extending each side by an equal amount. If the area of the garden and path together is 1.173 times larger than the area of just the rose garden, how wide will the new path be? So with any word problems, you need your let statement, and if you can use a diagram, and in this case the diagram is helpful, then you should do that. So what we're going to do for a let statement is we're going to have let the extended amount equal x. So initially, this was our rose garden. And the dimensions for this were 20 by 30. So what they said that they're going to do is they're taking a pathway and they're going to extend it the same amount on all of the sides. So we said that extended amount is an x, so they're extending it x here, x here, x here, x this way. So if I drew that to make my new dimensions, oops, we'll pretend these touch. So these values here are all x's. Okay. Okay, we know from the information that they gave us that the rose garden our area is equal to length times width, which was 20 by 30. So it's 600 meters squared. They told us the garden with this new path that they're putting all around it. Our area for that is going to be the 600 meters squared from the original dimensions of the garden, and they tell us here that it is 1.173 times larger than the area of just the rose garden. So if our rose garden was 600, the area with the new path is going to be 1.173 times larger, which means that this is going to be 703.8 meters squared. So this whole area from the garden and the path is 703.8 meters squared. So if we look at this, our length to find that 703.8 went from here to here. So our length started out at 30, but now we've added this x here and this x here, so we've added 2 x's to it. Our width, so going from here to here, was our 20, and our x that we've added on here and here, so it's 20 plus 2x. So those are our dimensions, our new dimensions for the whole area. So this was 20 plus 2x, and this was 30 plus 2x. So that means that the area, dimensions for the area of the garden and the path put together are 30 by 2x and 20 plus 2x. So my new garden and path, so I'll just put GP, my area is equal to my length times my width, so that's 30 plus 2x times 20 plus 2x. So I can multiply those through, and my area I knew was 703.8 is equal to 30 times 20 is 600. 30 times 2x is 60x. 2x times 20 is 40x. 2x times 2x is 4x squared. So I'm just going to rewrite this. I'm not going to make any drastic changes. I'm just going to flip sides and collect my like terms. So I have 703.8 is equal to 4x squared plus 100x plus 600. So now I can do my completing the square problem, which means the first thing I have to do is I have to move my 600 over. So I have 103.8 is equal to 4x squared plus 100x. I'm going to just reverse these and put my left side on the right side and right side on the left side. So I have 4x squared plus 100x is equal to 103.8. So my first step is GCF that 4. So I'm left with x squared plus 25x. I divide by 4. So I have x squared plus 25x is equal to 103.8 divided by 4. Which is 25.95. Okay, so now I can complete the square. My b is equal to 25. So 25 divided by 2, and then I have it, so I double the denominator. Sorry. It's just a 25. 25 divided by 2, so that's my keep value. Square it. And I'm going to change that to a 12.5 squared. Because I'm working with dimensions, it's okay if I put it to a decimal. So 12.5 squared is 156.25. So I have x squared plus 25x plus 156.25 equals 25.95 plus 156.25. So I have a perfect trinomial square, so this is x plus 12.5 all squared. And this equals 182.2. So now I can finish with the square root property. Square root both sides. So I have x plus 12.5 is equal to plus or minus square root of 182.2 is 13.5. So I have to bring that 12.5 over, so I subtract by 12.5. And I find my two solutions. So I have negative 12.5, x is equal to negative 12.5 plus 13.5, so x is equal to 1. The other one would be x is equal to negative 12.5 minus 13.5, which is a negative, what's that, 26, which I reject because I can't have a negative value. So my x is equal to 1.0, so that means my new path, and I kind of gone over here. New path will be 1.0 meters wide. And then you're done. So you have your questions that we'll work on in class.